always opposes in motion. It always opposes motion. Okay. It's not helping in motion, but it always opposes motion. Okay. So friction is a type of force which always opposes motion. So here you have an example is given. You can see a book is kept on a table. So a book is being kept on a table and you have to push that book gently. So when you push that book gently, we observe that the book stops after traveling a small distance. Okay. Here in this picture, you are shown the previous place of the book and the new place of the book. So here you can see that this is the original place, and when it has been pushed, so now it's here. So there is a change of position, but what actually we observe here is that the book stops. Okay, the book stops when it is pushed. It travels a certain distance and then stops. Okay, so once all of you turn on your cameras, all of you keep your cameras on. Okay. Okay. So here, what is the force that is being making it stop? As we know, a change in motion, or if there is a change in motion, so that must be brought about a force, right? So here, the object was continuing to move, but suddenly it comes to a stop. So that stop of the object, it is due to the friction between the two surfaces. Here, the friction between the two surfaces makes this block stop, makes this book stop. Now, the second thing here we observe two students. Here we observe these two students. They are slipping on a banana peel. So they slip off on a banana peel. Once you step on a banana peel, so you get slip off. So any reason why we get slipped off when we step on a banana peel, or when we try to walk on a marble floor, or suppose if you try to walk on ice. If you try to walk on ice, so we have, I think you must have seen our vehicles slipping on ice roads. Yes, if the road is covered with ice, so the vehicle generally slips off. Why we have the vehicle slipping off on icy roads? Why we slip off when we step on a banana peel?
Because it does not contain more friction, sir.
Yeah, because it does not contain.
More friction.
Yes. See, if you have a banana peel lying on the surface, the friction between the two surfaces reduces. Okay. Due to the reduce of friction, we fall off, we slip off. The similar happens when we try to walk on suppose we try to walk on ice. So if you try to ever walk on ice, you will fall off. The reason being that the friction between our feet and ice is very less. Since the friction between the two bodies is less, so we fall off. Here we observe that the reason behind which helps object to stop, that is friction. Okay. Now here you can see we have done the same activity in two ways. First of all, we have pushed the book in the right direction. So here we pushed the book towards right, and here we push the books towards the left. So now see what point is to be observed here. When we pushed it towards the right, so what was the direction of friction? In which direction did the friction acted?
The opposite direction.
Towards the
Opposite direction. That means towards the left direction.
Yes, sir.
Yeah. So this is the direction of motion in the first case. And in the second case, we observe here. Here in the same case, we observe this is the direction of friction. So can we say that friction is opposite to motion?
Yes, sir.
Yes, sir.
Yes. Now in the second case, see, we are making the book move towards the right. Now the book is moving towards the right. So this is the direction of motion. And what is the direction of friction then?
It's the same direction.
No. Now the
opposite,
friction
sir.
acts in the opposite direction. Now the friction acts towards the left. So friction always act in a direction opposite to the direction of motion.
So, sir, the like in the
Hmm.
figure A and the figure B, they're reacting in the same like opposite direction, only, right, sir?
Hmm. Yes, continue.
Sir, in the figure A and B, they both are acting in the same opposite direction, right, sir?
Yeah. Okay. So always it friction, the direction of friction is not left or right. The direction of friction is opposite to motion. If an object is moving towards the left, the friction will be towards the right. If an object is tending to move towards right, the friction will be towards the left. Okay. So is it understood that friction is always in a direction opposite to the direction of motion?
Yes, sir.
Yes.
Yes, sir.
Friction is always in a direction opposite to the direction of motion. Okay. In your higher classes, you may study some more details about friction. But for now, we are like this. That is, when in whatever direction the object is moving, the friction will be acting in its opposite direction at the same place. Okay. When the object is moving towards right, the friction is towards left. When the object is moving towards left, the friction is towards right. Okay. And what work is friction doing here? Is friction making the book move?
No, sir.
Yes, Sir. sir.
No. No, the friction is not making the book move. It is opposing the motion.
Sir, it's
It's
making
not.
stop.
Yeah, it's making stop. So friction always tries to stop the motion. It does not allow the motion.
Sir, my dad said that railway tracks are containing less friction.
Yeah, the railway tracks, they contain less friction. The friction on the railway tracks is less. Okay. So today we'll discuss about some more activities. Okay. Here you have an introduction of factors on which the friction depends. What are the different things on which the amount of friction depends? And for that, we have an introduction of an instrument called the spring balance. Okay. So is there anyone who has seen about the spring balances? Who knows about
Yes,
what
sir.
is
Yes,
Yes,
sir.
okay. Have you seen the spring balance?
Yes, sir.
no, sir.
Yes, sir.
Okay, see, if you observe here only, so the spring balance, a diagram of spring balance is given here. A figure of spring balance is given here. You can observe there is a little spring inside it, and there is a place to hang any object. You can hang any object at the bottom. Okay, so here you can hang any object. Now, depending on the weight, as the gravity pulls it, so depending on the weight, an extension will be produced in the spring. Okay, now whatever extension is produced in the spring, accordingly, we can read out what is the mass or what is the weight of the object. Now, a very good quality of the spring balance is that it can measure both the mass and the weight. Both mass and weight can be measured by a spring balance. Okay. So how it can be measured here? Uh, in this particular spring balance, we have just the measurement of mass on both the sides. It's the grams which are written. Can you see? Is it visible to all of you? That we have on both the sides grams written. Okay, I'll show you a spring balance which can measure both mass and weight. That means it will be in gram and newton. Both will be written on it. Okay, so let us say a spring balance which can measure both the things, which can measure the mass also, and it can measure the weight also. Okay, so let's see some spring balances and what all they can measure. Spring balance. Okay, you can check any of them. I'm just showing you one of them. And if I will be able to zoom it out, so I will show that the spring balance here, Mm, 1 second. Okay. So I think in this you can it is visible. Can you see the markings which are given?
Yes, sir. One is Newton and another is grams. But
Yeah. So
uh,
yes,
what is the F beside the G?
GF means gram force.
Gram.
Sir,
So here
GF
we
is
have,
known as mass, right?
yeah, it's the mass which is measured in gram force or gram. So just I'm making it elaborate to you that a spring balance can be used to measure the force as well as the mass of the object. See? So here you have on one side, you have the markings in Newton. On the other side, you have your markings in gram force, which are your masses, which is your mass in grams. So if it's 100 grams, that is equal to 1 Newton. 200 gram is equal to 2 Newton. So I told you your mass multiplied by 9.8. So which we roughly take it to be 10. That gives us the weight in Newton. So that's the same thing here. If you multiply 100 gram, that means 0.1 kilogram by 10, you get 1. 0.2 kilogram by 10, you get 2. 0.3 kilogram by 10, you get 3. So the spring balance, it is used to measure mass and force. It can be used to measure both mass and force, right?
Sir,
Yes.
where it is marked as N, 0, 1, 2, those are the newtons, right, sir?
Yeah, they are the newtons. And the other side, it's gram.
Gram.
Yeah,
Okay.
0, 100, 200, 300, 400, they are gram.
Okay, sir. Thank you.
Okay. Now, see, we can use this spring to measure the force. We can use this spring to measure the mass also. Now, in the coming activity, we will be taking the use of spring balance to measure the force. How we can measure the force using this spring balance. So let's see the activity here where we measure. So in this particular activity, we will measure the force. Okay, see here, we are studying the factors on which the friction depends. Okay, so you have a brick, a heavy brick being tied to a thread, and the thread is being pulled by a spring balance. Okay, so we have the this brick being pulled up by a spring balance, right? So whatever amount of force is required to bring this brick in motion. See, if you will apply a small amount of force, you will not be able to pull it up. Okay, it's not very easy to pull it. So if you apply a small amount of force, if you see initially at let's say 1 Newton or 2 Newton, you may not be able to pull this brick. If you try to do this, so you require some larger amount of force. So as you increase your pull, the spring balance will show you readings. Now you have to note the reading at which the brick starts moving. It just begins to move. Okay. So we have to see that what is the force required at which the brick just begins to move. Okay. So this is we can use a spring balance. I'll try to show you in the coming classes with the spring balance. I'll try to do this activity and show it to you. If you have a spring balance, you can try it out at home also. But if you don't have, I'll try to show it or record a video for this and then show it to you, share it with you. Got it?
Yes, sir.
Yes. So I'll try to do something regarding this amount of force that is required to pull this brick. Okay. So here, see how much of force is required. So in this case, suppose we require some amount of force. Let's say we require 20 Newton of force. Suppose, okay, we do not know the exact value. Suppose in this case, we require here 20 Newton of force. Now the second we have to do is, we have to cover the brick with a polythene. Okay, we have to cover this brick with a polythene, and then we need to need to do the same thing, and we need to observe that yes, what is the amount of force that is required. Okay, So let's see here. The second thing, now wrap a piece of polythene around the brick and repeat the activity. So do we require the same force?
Sir, I doubt that,
Yeah, what is expected out?
sir, I
What
did,
we, yes?
sir, I didn't understood that 9.3, that 12.3 blank, sir. What you just explained, the vapor polythene
What,
activity, sir.
yeah, activity.
12.2.
Yeah, you want activity 12.2 again?
Yes, sir, I didn't understood.
Okay. See, in the beginning, you are taking a brick and trying to pull that brick. Okay. So we are applying the force through the spring balance. We are pulling the brick through this spring balance and the thread. Okay. So we observe here what is the amount of force that is required to bring this brick in motion. Okay. Minimum force required to bring this brick in motion. Okay. Initially, the brick is in the state of rest. We are applying some amount of force. So we want to see how much of force is required to bring this brick in the state of motion. Now, we note down what is the amount of force required. So suppose here we require 20 Newton of force. Okay. Now the second thing we have to do is we have to wrap the brick in a polythene. Okay. So wrap this brick in a polythene and then try to pull it.
Sir,
Yes.
what is there in the spring balance, sir, that it shows the number? Like,
Yeah.
what is there in the spring balance, sir?
That's the blade of the spring balance which is attached to the spring.
Okay, sir.
This one you are saying?
Not that blade, sir. Inside.
Where inside?
Inside the spring balance, which shows the units.
Yeah, that's the mark. That's the pointer. Okay, inside the spring balance, you have the pointer which points to the amount of force that you have applied. So it will show you what is the amount of force that is being applied for this brake to come in the state of motion. Got it?
Sir.
Okay. So here we do the same activity with two different surfaces. First, we applied the force as it is. Then we change the surface by wrapping the brake with a polythene. So when you wrap the brick with a polythene, this will lead to decrease of friction. This will lead to lesser force. So in the first case, if you are applying a force of 20 Newton, if you wrap the brick, you may apply a force of nearly about 15 Newton and the brick will start moving. Got it?
Sir, can you explain again?
Yeah, Gagana. So, so see, basically you are doing here, first time you are pulling this brake with the help of spring balance, and then second time you are pulling this same brake with the same spring balance, but now in the second case, this brake is wrapped with a polythene. If you wrap this brake with a polythene, the surface which exists between the two surfaces is new. Now it's changed. It's a smoother surface. We observe that a polythene is a smoother surface and the brick itself is a rough surface. Okay. So we observe here that there will be large amount of friction acting between the floor and the brick. So the brick does not move quickly. It takes some time. It takes a large amount of force for the brick to move. The second case is when you wrap the brick with the polythene, so you require a lesser amount of force to pull it. But now
Yes, sir.
let's do, okay, here is another activity. Okay, so this activity will also explain it. So in the previous one, we understood here that the force of friction depends on the nature of surface in contact. This activity explains that force of friction is dependent on the nature of surface. To understand that, we have another activity here. See, these two students, they are trying to play with a cell. Okay, you must have played like this. So they have taken a table, and on this table they have put an inclined plane. Okay. So on this inclined plane, they marked a position which is mark A, and from this point, they always release a cell and observe up to how much distance does this cell travel. Got it? So they are making it to say that how much distance does the spring balance travel? Does this cell travels? So here, suppose it travels certain distance which is marked over here. It is shown here. Now in the second case, they put a cloth on the table. So here, see, they have put a cloth on the table, and now they again drop the they again drop this cell from the same height, from the same inclination, and you observe that the cell travels a smaller distance.
Sir, by this activity, we will come to know that friction is more on the cloth, sir.
Yeah, there is more friction on the cloth and there is less friction on the table. Okay. So we observe here that friction is dependent on the nature of surfaces in contact.
Sir, once could you scroll up, sir?
Sir,
Yeah, sure.
I will see the A.
Just one second. I'll make it visible. Okay, here. Both are in the same frame.
sir,
Yes.
as you told that the Springer something that device, no, sir.
Something that
Sir, previously you told that device, no, sir.
I told you that friction is dependent on the nature of surfaces in contact. Okay. So,
Okay.
see, nature of surface means here we have a smoother surface. The table is a smooth surface, and here if we put a cloth, so it makes the surface rough. Okay. And now we are making this cell go down from here. We are putting the cell here at the same mark. So it travels this much of distance. And again, we put the cell at the same mark, but now we put a cloth on it. Now we put a cloth on the table. So we observe that the spring, that this cell, it does not travel the same distance. It stops with a smaller distance.
Sir, means rough surface does not have friction, that much friction, but smooth surfaces have more friction.
Yes, there is. Smooth surfaces have less friction and rough surfaces have greater friction.
Okay, sir.
The
Sir,
cloth,
The lesser the friction, the lesser the force.
yeah, the lesser the friction is the force that opposes it. See, so here the cell is able to travel a larger distance because there was a force of friction which was acting opposite to it. So here the force of friction was opposite to the direction of motion. Okay, so we can say that here some amount of friction acted, that is why the cell stopped. In the second case, here also, the cell travels a certain distance, but now this distance, let this distance be small d, let this distance be capital D. So we observed here that this distance in the first case is greater than the distance in the second case. Got it? So why it is so? Because here friction was opposing with a small amount of force. There was less frictional force, and here there was more frictional force. So that is why it stopped with a smaller distance.
sir, what if we increase the size of the inclined plane, sir? Does it move a long distance?
Yeah, if you increase the height of the inclined plane for both the cases, so for both the cases the distance will increase. The distance to which the cell will go, it will increase.
Why, sir?
Because as you are increasing the inclination, you are increasing the height. And when you increase the height, the energy of the spring, the energy of the cell increases. Yes, it has more amount of energy,
Like
So
the
it will
potential,
travel a greater distance. Yes.
if it is in the rest in the initial point, the potential energy will be more. So the pressure will be more then.
Why you are involving pressure here? We are just talking of potential energy. So
Yes,
if you are okay, so even if let's say you have a mark here, they have marked this point as A. So if you mark another point here B and release the spring from here, so you are increasing the height. And if you increase the height, the potential energy increases, and hence the cell will travel a larger distance.
okay, sir.
Got it?
Which force,
Sir, like
which force pushes the cell from the inclined plane, sir?
Yes. Which force pushes the cell from?
The initial point.
Okay. Now you will tell which force is pulling it down. Which force is pulling the cell down? Who will tell? Charantej, can you tell? Which
sir, may
force is?
I
I think
Yes.
gravitational
I
force, sir.
want to try,
Sir,
sir.
frictional force.
Frictional
No.
force.
I think
No.
gravitational
The
force.
Frictional force is
gravitational
not
force.
Gravitational
pulling it
force.
down. Yes, it is the gravitational force which is pulling it down, and it is the frictional force which is opposing it,
Yes,
right?
sir.
As gravity pulls all the objects downwards. So when we are taking the help of this inclined plane, so it is the gravitational pull, gravitational force which is pushing it down. As the gravity pulls all the object downwards. So it is the gravitational force which pulls this object downward.
Sir, so lesser the height, it travels
Ye-
lesser the distance.
Yes, lesser the height, it will travel lesser distance. And greater
More
the
height,
height,
it
it will, yes,
greater distance. More height, like greater the height, it travels with a greater difference.
yeah,
The
but that is the concept when we are doing for potential energy. Currently, we are just involved with friction. Okay, so we want to make them move from the same height. We want to release them from the same height so that we can see that if I'm providing the same amount of energy to both the cells, so which one will travel a larger distance. So clearly, we are able to study here the effect of friction. You can try to do this at your home also. Okay. If you do not, if you do not have a cell, you can take the help of your small toy cars. Okay. You have a toy cars, you can have your pencil. So those can work. Got
Sir,
it?
we can use gravitational force as non-contact force also, sir.
Yes, pardon.
Sir, can we say gravitational force as even non-contact force?
Yeah, gravitational force is a non-contact.
Okay, sir.
Okay, gravitational force is a non-contact force, and frictional force is a contact force. So everyone has understood this activity.
Yes, sir. Sir, why
Okay.
height and the potential energy are directly proportional? See?
Yes, height and potential energy, they are directly proportional to each other.
Why, sir?
Why? Because if you have to take a ball to a height, okay, suppose you want to lift something to different height. You want to lift, these are the two heights. I tell you to lift a brick from ground floor to the first floor and the second floor. So where do you need to do greater work? Yes, Pranava, where do we need to do a greater work?
In first floor, sir.
For first floor or second floor? I
second,
want to, for the second floor. I
Second
want to lift it from the same point to first floor and second floor. So if I'm doing it for the second floor, I require a greater amount of work. I need to do greater amount of work. So that is why when it is at the second floor, it will have greater potential energy. And when it is at the first floor, it will have lesser potential energy. Okay. You can say that our work done is same as the potential energy. Got it?
yes, sir.
Okay. So from these two activities, we are concluding that the friction is dependent on the nature of surface, right? Friction is dependent on the nature of surface. So the topic we were doing is that What are the factors on which friction depend? So here we concluded that friction depend on the nature of surface in contact. If the surface is rough, the friction is higher. If the surface is smooth, the friction is lower. Okay. So shall we move ahead in the next topic?
Yes, sir.
Okay. Okay. So why do you think that it happens? Why do you think that it happens that friction is dependent on the nature of surface? Why is there a greater friction on a rough surface and lesser friction on a smooth surface?
Because there are lots of irregularities on a rough surface and less irregularities on a smooth surface.
Yes, yesterday we studied about the irregularities. We
There are lots.
studied that friction is caused by the irregularities. So on the smooth surface, here you will have lesser number of irregularities, and on the rough surface, the amount of irregularities will be high, something like this. So that is the reason there will be high friction. There will be high friction here and low friction on the smoother surface. Got it? Okay.
Yes, sir.
Sir.
Yes. Okay, see here. The same thing has been explained in the diagrammatic way. The surface irregularities have been shown here for the two surfaces. Okay. Now the second thing here, another activity. Dependence of friction on the weight of the object. So if you want to push a heavy object and if you want to push a light object, so where would you require greater amount of friction?
To push heavy object.
Yeah, to push a heavy object, we require a greater amount of force. Suppose I want to push a box, a heavy box. So would I tell a 5-year child or a 14-year child?
14-year child.
14-year
14-year
child.
child.
The reason being that he will be able to apply a greater amount of force. Okay. And because of that, since he will be able to apply a greater amount of force, the small child will not be able to move it. The reason is that a heavy box has a heavy box applies greater friction, whereas a light box applies a lesser friction. Okay. So today we studied these two things about friction. So first thing, why there is friction? So we studied that why there is friction.
To stop
Friction is there due to irregularities.
To oppose the
spring
force.
balance. Sir, even spring balance.
Yes.
Spring balancing.
Yeah, you want to explain spring balance again?
No, sir.
Okay.
Like you're asking like what we learned today, right? So that perhaps.
Yeah. Very good. Very good. Thanks. So friction is there due to irregularities of surfaces. Then we have seen that spring balance is used to measure force. A spring balance can measure force. So up to now we did not have, you have not studied about any of the instrument which can measure force. So now we studied the spring balance can measure the force. Right? So here we studied that a spring balance can measure force. The second point we make here, first is friction is there due to irregularities of surfaces. Then the second point we did here is that spring balance can measure force. Now the third point here which we did is the friction is dependent on the area of contact. Sorry, friction is dependent on nature of surface. Nature of surface in contact. So you can say we have done here that a rough surface has a greater friction.
The smooth surface have a less friction.
Okay. A rough surface offers greater friction. And a smooth surface offer less friction. Got it? A rough surface offers greater friction and a smooth surface offers less friction. Then another point we studied about friction, that friction is directly proportional to load or weight. Proportional to load or weight. So if you have, so for this we had seen that a heavy object,
So you told the activity you will give it today's class.
yeah, I will give you the activity in today's class.
You told, sir, like yesterday's class we don't have time, so you told that you will give it today's class. You told to divide.
Okay, I will give you an activity. So can you perform any of these activities like we have done today? Okay, at the home, I think if you can do any of these activities, like I think you can do the rolling of that cell.
Plane.
Yes, sir.
Yeah, with
That
an
plane.
inclined plane. That one you can do. Okay, so
Yes,
I would
sir.
like you, to do that activity and send that activity either in the support group or send that activity to my number also. I'll forward it to ma'am.
It's the support and feedback group, sir.
No, it's not in the support. I will just forward it to my number. You can check my number from the group also. Okay, so you can send it to me with your name. Write your name also. Okay, and send a video if you have done this activity any of.
Okay, sir.
Okay, so
Yes,
friction
sir.
is directly proportional to load or weight. So a heavy object offer greater friction. And a light object offers less friction. Got it? So can we end up today's class now? Your homework is doing of activity. So make a video of your activity, which you can do for the rolling of the cell. Okay. Bye. Bye all of you.
Bye,
We
sir.
need to only send it to
Thank you.
your number.
Yeah, just send it to my number. So I'll be forwarding it to them.
Yes, sir.
Okay. Okay. Bye.
Thank you, sir.
And
Bye, sir. Thank you, sir.
okay. Bye.
Sir?